What about solving a system of three equations using a matrix and getting it in a reduced row echelon form? It's going to be a little bit of work, but it's a little more methodical than just doing it straight up with the equations themselves. So we once again take all the coefficients, all the numbers here, and translate that into a matrix. Be careful, this third equation is missing a y term, so you put a 0 in for that middle column. All right, now our goal is going to be to get ones along the diagonal and zeros below. So we always start with the upper left and get a 1, then we'll get our zeros, then we get the next one, and then the 0, and then the last one. All right, well, the easiest way to get a 1 up here on the top is just switch these two rows. So that's what I've denoted here. Then it gives me this matrix here. I know it looks a little messy. I'm trying to put in the details for you. I need to now turn this 2 into a 0 and this 4 into a 0. I can't multiply by 0, but I can add a multiple of this top row. If I multiply the top row, everything in it, by -2, and then add it, I would get a 0 here. So that's what I'm saying. -2 times row 1, add it to row 2, and replace the row 2. So multiplying each of these by -2, I would get these results. I'm going to add those to each one of these entries, and we get our 0, 5, 5, and 10. All right, now what about the bottom row? Well, I'd have to add a -4. So let's take the top row and multiply every entry by -4, add it to row 3, and replace row 3. So that's what I'm showing here. So multiplying each one of these by -4 gives me these results here in blue. And then adding, we get our 0, our 12, 13, and 27 in this matrix. Okay, so we've got the first column done. Now I need to turn this 5 into a 1, and I always can get a 1 by multiplying by the reciprocal. So if I multiply by 1/5 every entry here, we've got our 1s, the 1, 1, and 2. All right, now last thing I need to do, well, not last, almost last, I need to get a 0 below here. So I'm going to use the multiple, not of the top row this time, because that might mess things up. I just need to use a multiple where the 1 is. So I'm going to multiply this second row by a -12, and then add that to our third row and replace the third row. So I'd add -12 to 12, -12 to 13, and -24 to my 27, and look what happens. We actually ended up with a 1 here where we needed it on the rest of our diagonal. So we can quit with the operations and just translate back into equations. X minus 3y minus 2z equals -1 from the top one. The next one says y plus z equals 2. And the last one very simply says z equals 3. So back substitute z up here into the second equation, and we'll find that y is -1. Then I take my z and my y both and plug them into the top equation and find that x is 2. So 2, -1, and 3 would be our answers. Okay? It would be really nice if they were all as simple as that last equation. If we had what we call reduced row echelon form, where there's 1s on the diagonal and 0s below and above those 1s, because then we'd have just like z equals -2, but we'd also have y equals whatever the answer is, and x equals whatever the answer is, and we wouldn't have to substitute. Since we're going to use the calculator to get this final reduced matrix, it can go a few extra steps without any trouble. That's what we're going to do, and that's what you want to watch in the next video.